Okay, so in this lesson, I want to go over systems of special cases. Case 1, if the variable drops out and you get a false statement, that means no solution. Case 2, if the variable drops out and you get a true statement, that means there's infinitely many solutions. So let's look at this example 1 and let's do it using the substitution method. And you can see we have a variable already by itself. So I am just going to substitute where the y used to be and put negative 3x plus 6 where that y used to be. So negative 3x minus, and I have put a parentheses, negative 3x plus 6. So I put a parentheses where that y used to be, equals 12. And that's where most kids will make a mistake, is they won't put that parentheses there, because then you have to distribute that negative. And that's where most kids make a mistake, is they don't put that parentheses right there when they substitute. And then just your algebra skills, right? You distribute negative times a negative 3x is a positive 3x. And a negative 1 times a positive 6 is a negative 6. And then when you combine like terms, don't the x's drop out? And doesn't that leave you just a negative 6 equals 12? And that is, so what happened was our variable dropped out, right? There are no more variables in the sentence. Where'd they go? They dropped out because negative 3x plus positive 3x is 0 x's. That means we have no more x's. So the variables dropped out and negative 6 does not equal 12. So our final answer is no solution. So let's just take a moment and say, what if we graph those? Like, what if we took the equations and graph them? So if I graph this equation, I would use y equals mx plus b, start with the y-intercept, and then go down 3 and over 1, and I can also go up 3 and over 1, and down 3 over 1, down 3 over 1, down 3 over 1, and there's my line for the first equation. So I did that in black, and then when I do the second equation, was negative 3x minus y equals 12. I have to put it in y form. That negative 3x becomes a positive 3x. And then I have to divide everybody by negative 1, and that gives me y equals negative 3x minus 12. And I probably don't have 12. Let's see, 2, 4, 6, 8, 10. So negative 12 is about right there-ish, right? I'm just using my eyes to kind of eyeball it. And then I'm going to go up 3 and over 1, and up 3 and over 1, and up 3 and over 1. And when you do that, it's not the best, but what do you notice? We have parallel lines. And so remember the solution. So we have parallel lines. And aren't we looking for where the two lines intersect? And they don't intersect, so isn't that no solution? So see, it matches what we did algebraically. So yesterday's homework, we were solving the systems by graphing, and if you graphed it, notice you would also get no solution. So, but algebra is a lot quicker because graphing can get really ugly, it can get kind of messy. So it's a great method to finding a solution to a systems, but algebraically can get you more exact and precise answers. And so learning how to do the substitution method or elimination method is important. And this is what happens in special cases when the variable drops out and you get a false statement. That means it's no solution. And that's because if you were to graph it, the lines would have been parallel, right? You didn't actually have to graph it. I was just kind of showing you, but what if? What if we graphed it? What would that do? Okay, so let me move and erase a little bit to get that out of the way. So what if we had this problem here, example number 2? In example number 2, we are going to use the elimination method, right? And so I want to be able to get one of the coefficients to be opposite. So either the x's or the y's to have opposite coefficients. So when I add them, I will drop out a variable. So I notice that if we multiply by this equation by a 3, and that would give me negative 3x plus 6y equals 24. Don't forget to multiply 3 to every single term. Some people they always leave this guy out and they just copy 8. It's a common error. And then I'm just going to recopy the top equation. So the top equation, I don't want to touch it. I want to leave it alone. I only wanted to multiply 3 to the bottom equation because, look now, I have a positive 3x and a negative 3x is no x's. A negative y and a positive 6y is no y. So we have nothing on this side, and you have to say that. You can't just stop and say in your head that, oh, it's a no solution. Like, you have to show evidence that supports how you got there, just like we did with absolute value equations where you ended up getting no solution. You couldn't just, in the middle of the problem, just go, boom, it's no solution. You had to have supporting evidence, right? And so on this side, 2 plus 24 is 26. So that's what everybody's work should look like. And then from there, you can conclude that the variable dropped out and I ended with a false sentence, therefore it's no solution. So you have to show the complete evidence of your work, and this line is the most important, right? You don't forget to show that you're adding the two equations, and then therefore you can have, this is your final answer, right? So you have to have your supporting evidence that supports your work. So that's how it would look like if you were doing, for an example, if you were doing an elimination method, there's an example of what a no solution would look like. So that was case 1, right? Let's go to case 2. If the variable drops out and you get a true statement, that means infinitely many answers. So let's look at that situation. Okay, so we're going to do substitution again for this problem. And so I don't know if you noticed it on this problem, but since this says 2y and I have a 2y right here, can't I just take this and put it in place of the 2y? And you're like, what? Can you do that? Well, when it has an equal sign and it says orange equals 3 avocados, that means if you see an orange, you can take an orange out and you can put 3 avocados in its place. So if it says 2y equals blah, 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 and you see a 2y can come off the field and all of that stuff can go in place of 2y. So maybe you didn't see that right away because you weren't thinking like that. So most people probably would have said, oh, I've got to isolate the variable. So I'm going to get x by itself, and that gives me 2y minus 7. And then I'm going to substitute that in place of that x in the second equation, which you certainly could do. But I just wanted to show you something higher level and just kind of get you to think outside the box a little bit and understand what equals means. Equals means you can pull that guy off the field and put somebody else in its place. So I'm going to go back and use that strategy. So did you learn something new today from an Algebra 2 perspective? So again, since I have 2y, I can say all of this is going to go in place of this 2y because this says wherever you see a 2y, it can come off the field and you can put all of that in its place. How cool is that? So that's going to give me x minus, and remember, I've got to put that in parentheses. And then I got to distribute. And then isn't a positive x, right? That's 1x and negative 1x. So doesn't the x's drop out? And doesn't that leave me negative 7 equals negative 7? So didn't the variables drop out and didn't I get a true sentence? So doesn't that mean there's infinitely many answers or solutions? But I want you to actually solve. So I want to know what are the solutions. So if I said it depends. If I said, how many solutions would you get? In the first example, you would say no solutions. If I said, how many solutions would you get? You would say infinitely many. But if I want you to solve, that means I want to know actually what are the solutions, right? What are they? So when it's an infinitely many, we have to do parametric form. And I'm going to go over parametric in a second. Let's look at what if we were to graph these two equations. Let's see what would happen. So if I graph the first equation, so let me do a little erasing. Let me erase up here. If I graph the first equation in red, that would be this guy. I would want to get y by itself. So if I divide everybody by 2, that would give me 1/2 x plus 7/2, which is 3 1/2. So I would go up to 3 1/2 right, for the y-intercept, and then I'm going to go up 1 whole unit and over 2, up 1 whole unit and over 2, up 1 whole unit and over 2, down 1 whole unit and over 2, down 1 whole unit and over 2. So there's my line for the first equation. Now I'm going to do the second equation in blue. The second equation is x minus 2y equals negative 7. To graph, I'm going to put it in y form. So I have to use my algebra skills. That leaves me 2y equals negative x minus 7. Divide everybody by negative 2. So that gives me y equals a negative divided by a negative. That's going to be 1/2 x. Do you see why it's 1/2? Because it's that coefficient of 1, right? So that's a negative divided by negative is positive, and that's 1/2. And then a negative divided by a negative is positive and 7/2 again. So doesn't that mean I start at 3/2 and I go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2? So what happened? Wasn't it the same line again? So when I graph those were actually the same line. So they're on top of each other. So it's two lines that are exactly the same line. So they're on top of each other. So how many times do they intersect? Lots. Don't they intersect here and 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 between those and between those and between those and between those and forever? So isn't that why we write infinitely many? Don't they intersect in all kinds of places forever and ever and ever? So that's why there's infinitely many, because there's infinitely many intersections. So some students say, well, couldn't we just write our answer as all real numbers? Do you have any idea why that you cannot do that? Like, why can't we just say all real numbers? Or, right, why couldn't we write our answer as all real numbers? You have an idea? I'm going to let you think about that as I'm erasing. So why couldn't we just say all real numbers? Well, let's see if you figured it out as to why you can't say that. Is this point right here a solution? Nope, because it's not on the line. Is this point right here a solution? Nope, because it's not on line. So that's the reason why you can't say all, because if you said all, you mean every single point on the coordinate plane is a solution. And that's not true. Only the ones that are on the line is going to be a solution. Because remember, there are two lines that are on top of each other. So they actually have to be on the line to be a solution. So now, how do we actually write our answer in what we call parametric form? We're going to use an XY ordered pair. And we take whichever equation we want. Like, let's take the top equation. And if we solve for y, that and get y by itself, divide everybody by 2, that gives me this. So that means this goes where the y used to be. So that's what goes where the y used to be. So that means my answer would be, so I'm going to erase that. So my answer would be x, comma, and then where y used to be, I'm going to put 1/2 x plus 7/2. And that's called parametric form. So if I asked you, give me a solution, you could pick any number for x. So for an example, let's say we picked 6 for x. Then we could plug in 6 into there. So 1/2 times 6 plus 7/2 would be 1/2 times 6 is 3. Remember, this is 3.5, so that would be 6.5. And if you plot 6 and 6.5, you will see it landed, there it is, right there, it landed on the line. So this is basically a map that will give you solutions that land on the line. So it is a map that basically says you pick any number you want for x, plug it in, and that will be a solution. And you can say, well, I'll plug in 0. I'll plug in -2. You plug in whatever you want. And obviously, you couldn't list them all because there's infinitely many points. So that your answer is just the map of how you would get your answers, right? Because we obviously couldn't list them all. So hopefully that wasn't confusing. Just wanted to add, what it was. Now, you can also do it the other way. So there's two possible answers. So for an example, we could take the top equation or the bottom equation. Doesn't matter which equation, top or bottom. I'm just going to use, I'll use the top equation again. And I could solve for x, which means if I move the 7 over, that gives me x equals 2y minus 7. And so I would put in place of the x, I would put this in place of the x, which is 2y minus 7. And then y would be what we call a parameter. That's the one that you get to guess. And you can put any number you want in that place. And then this is the map. Which map do you think is easier to use to find solutions? Well, this one, because it doesn't have fractions, but it doesn't matter. Both are correct. You only have to give me one of them, right? You only have to give me one of them, but they're both correct. I would have preferred this one myself because it doesn't have fractions in it, but it's not a big deal. Both are correct, and you only have to give one mapping of the solutions, and that's called a parametric answer because it's infinitely many, and we have to describe the points that are on the line. Sometimes on SATs, I don't know if they'll say it on an SAT, they might just say any point on the line. So they might say, any point on the line y equals 1/2 x plus 7/2, right? Any point that's on that line. But I wanted you to show you parametric answer because we've been seeing parametric answers on SATs. Okay, and we want your answer in parametric. Okay, let's look at example 2. So let's clean this up and let's look at example 2. Okay, so on this example, we are doing the elimination method, and so we want to try to get opposite coefficients on at least one of the variables to get opposite coefficients. So I think I will multiply this bottom equation by just a positive 2. And when I do that, that gives me 2x plus 2y equals 8. And the top equation, I just want to leave alone. And when I add those two equations, that gives me no x's, no y, so I have nothing on this side. Super important that you say you have nothing on that side, and negative 8 plus 8 is also nothing. So what happened? The variable dropped out. I have no variable anymore, and I've got a true sentence, so that means infinitely many. In other words, if you happen to graph those, they would have been exactly the same line, and they would have been two lines on top of each other, and there would have been infinitely many. Remember why we can't say all real numbers? Because what about the points that are not on the line? Those are not solutions. So only points that are on the lines because they overlap, right? Now, let's do our parametric answer. So since it's infinitely many, we have to do our parametric answer. Pick any equation, either the first one or the second one. Either the first one or the second one, because they're really the same, right? If they're going to give you the same line, they're the same. I'll pick the bottom equation, and let's solve for y. So if I move x over to the other side, that gives me y equals negative x plus 4. So in an ordered pair, right, this is your x and this is your y, we're going to put, since this is y equals, this is going to go in place where the y was, and that's going to be our map to finding actual solutions. So our answer would look like x comma negative x plus 4, and that's one of our answers in parametric form, and it's basically a map where you could pick any value you want for x. For an example, if I picked 7, and then negative 7 plus 4 would make negative 3, so 7, negative 3 would work for both equations. If I picked 0, then negative 0 plus 4, 0, 4 would work for both equations, right? So that's the map that would give us solutions, and you don't have to, and you would just provide me the map. the parametric answer. And there are two answers. You only have to provide me with one of them. Right? What if you took this equation, but instead of solving for y, what if you solved for x? So what if we solved for x? So wouldn't that give me x equals negative y plus 4? So that means we would put this where the x was. So where the x is, we're going to put negative y plus 4, and then this is going to stay as y. So that's our other parametric answer. You only have to give us one of them. They're both correct, and you only have to give us one. So that's the example of our special cases, and with infinitely many, how to write your parametric answers. I hope this really helped you.